Good afternoon. Thank you very much to you all. Thank you to the WavEC and also to the Norwegian Embassy for the opportunity that this event will offer to all of us. It's for me both an honor and a pleasure to address such a knowledgeable audience. And a special welcome to our Norwegian visitors, which I hope will be future partners. I will address the topic about... Do I have the presentation ready? Okay. I will show you the vision. Of course, it's a combination of structural adaptation, but also the formulation in terms of strategy. First, I would like to give you a short overview about the structural adaptation we did with the new governmental vision. My Directorate General is there represented, DGPM. Which is responsible, as you may see, for the National Ocean Strategy, the Action Plan coordination, cooperation, and Marine Special Planning coordination as well. Also, we have the DGRM, which is responsible for the operational side of the governance. So he's responsible for the licensing, regulations, and things like that, mostly. On the other side, we also have fused some of the scientific areas that used to be dispersed in several areas of the public institutions in a sole institution called IPMA, which is the Portuguese Institute for Sea and Atmosphere. And finally, we have what we may call a task force, which is specifically dedicated to the project regarding the extension of the continental shelf program. The other light blue areas are areas of different types of responsibility. DOCA Pesca is an enterprise, a public enterprise, which is responsible for the first auction of selling of fishing resources and aquaculture, and the CM is the Interministerial Commission for the Maritime Affairs, and I will explain a little bit about it. Is a structure, a government structure for the strategic thinking development and decision about sea aspects. Those are the objectives. Is chaired by the Prime Minister. It involves different ministers, is an interministerial framework. There is a focal point organization which I'm in coordination, and the Secretary of State for the Sea also has a place in this commission. Now, giving you a broad view about the strategy that we are thinking about shaping the ocean's future. If we look to the map and if we look to the project of extension of the continental shelf, that gives us an impression of one of the biggest submarine countries in the world. The area itself is around 40 times the area of the inland territory, and proportionally you may include all the territories of the European Union in that same area. At the same time, if we develop a maritime strategy, we will be able to move towards the west some of the major strategic ideas that Europe may develop in the future. And if we think that during the last couple of days, the last couple of years, the strategy was oriented towards the east, this is also a possibility to leverage again the visions of Europe towards the Atlantic, towards a maritime strategy, and towards its own competitiveness in global terms. And if you look to the Mar Portugal, you may characterize this submarine territory with some inland areas as a kind of border tops. But main characteristics are that they provide the intercontinental connectivity. All its regions, either littoral or insular, are totally focused on the sea. So every region is able to develop a strategy towards the sea. It's not just a question of the central administration. And the main characteristic of this submarine territory is that is very deep. Is deep sea and ultra deep sea. So the drivers for our vision to shape the ocean's future relies upon the deep sea natural resources access and marine environment and biodiversity preservation. The European Union intercontinental and regional cooperation on the ocean. Of course, this also embraces the enlarged European area. And research, development and technology for accessing the deep sea and also to provide us conditions for remote sensing in terms of Earth observation. You need to have in mind the big extension of the area and the broad terms of the requirements. And when we shape the ocean future, we have to formulate about what we call to be a sustainable development. And sustainable development needs to address coherently three main pillars: the economical, the social, and the environmental. Of course, there is an European Strategy 2020. It sets the path for the purpose. Of course, we need to adapt and give an ocean approach to this main end states in terms of sustainable development. So we develop strategies for blue growth, and you possibly heard about already. But it needs to be also a strategy that embraces social cohesion and territory integration. We should have central administration visions that are able to incorporate requirements of their regions and at the same time disseminate the big visions of a member state. And those are the 5 strategic objectives that have been set in the new National Ocean Strategy that is currently under review and should be in public discussion shortly. Of course, we need to improve in dynamics in the way we take our own decisions. We need to adapt to the conditions. We have to monitor the marine environment and its biodiversity. We need to get times and times more knowledge about we still don't know. And at the same time, we need to measure the human activity at sea and how activities cause pressure in the marine environment. We may say that we have maritime activities that are illegal. We may speak about piracy. We may speak about armed robbery. But of course, there are peaceful activities that need to be surveyed as well, due to the fact that they will cause impact and pressure in the marine environment. So if we want to manage properly the uses of the sea and to preserve what is essential, we need to monitor both sides, and we need to be dynamic in the way we take decisions, in the way we apply precautionary measures, and in the way we decide upon maritime exploitation of the resources. So there is also a requirement to cooperate, combine, and harmonize. Nobody is able to do that on his own. And those are the principles of what we may call the integrated maritime policy. Now, every strategy, either having a formulation part, needs also to be implemented, and that is the room for the action plan. There are a lot of failed strategies because we formulated very well, but we were totally unable either to plan or to monitor the implementation. That's where we try to invest and give more focus on the future national ocean strategy. And the action plan will address how to improve and innovate over the traditional maritime activities, but also how to address the new activities, at least for Portugal, in uses of the sea. We may speak about aquaculture, we may speak about new resources, marine biotechnology, and for the purpose of the audience, the marine energies, in this case renewables, but also the conventional sources of energy. But we look also to marine minerals and the raw materials that we may take out as well. And the strategic planning requires programming and projects. And this cooperation with the partners may identify possibilities and future ways to develop action programs and to develop projects. I'm responsible for proposing an operational program under the EA grants regarding the monitoring of the good environmental state of the national marine and coastal waters, but others, and in particular private stakeholders, may think about and may find ways how to develop programs and correspondent projects. Again, we need to cooperate, combine, and harmonize. And in the maximum extent possible, we also should try to build upon existing capabilities. This is the development model of the new reviewed National Ocean Strategy. Renewable energy is identified in one of the programmatic areas for which I'm responsible at the strategic level. Is a tremendous undertaking, but my team is fully motivated to address this action plan. There are a lot of challenges. Of course, there are also threats, but mostly what I can say is that I count on you to help me in this undertaking with your views and our recommendation and your recommendations. Sorry. Now, the challenges. I used to define challenges in 3 types: the central administrations, the EU, the UN, the member states, in how to implement and provide coherence to the integrated maritime public policies. But at the same time, when we speak about licensing, we speak about maritime special planning, and you name it. But there are also other tires, and we cannot forget and disregard the fact that we need to have a strategy that promotes social integration and territorial integration as well. So the work in the regions and municipalities is essential. They are the actors to make a strategy possible, because they are the ones which are in the action area. And finally, we have a third level, which is formed by the stakeholders of the economy, technology, and science. Most of you are of this, what I call the tier number 3. But of course, this is not so much hierarchical, it's just a way how to manage the work, because it's purely transversal. And we have to see the central administration more as a facilitator or an enabler in certain extent, but the tier 3 is the real group that makes a strategy a concrete action. And again, we have to cooperate, we have to combine, and we have to harmonize. And this was generically the vision that I brought to you here this afternoon, and now I'm in charge to moderate this important panel. And now, if you don't mind, I'm going to present some of our visitors and speakers here today. Thank you.
Thank you for the introduction. Can everybody hear me? As it was said, I'm the CEO of the ocean renewables company Straum. Straum is actually a consolidation of several technology companies, which I'll get back to. As was mentioned, we have several technologies. We both within the tidal technology, offshore wave power, and floating and bottom fixed offshore wind. Strohm, as was mentioned, is part of a larger industry group with more than 150 years of industrial experience in Norway, among other things from offshore oil and gas and hydropower. The owner group ARD is part of, has several industrial activities: NLI, offshore oil and gas; rain power is hydropower, and there are also some retail companies within the group, and real estate, in addition to Strohm. Over the last at least 10 years, the group has seen significant growth and are now a total of 3 billion in annual turnover for the entire group altogether. Strohm has a relatively small part of that at the moment, but we're hoping to be bigger. I'm going to talk about 3 of our technologies: floating offshore wind, tidal, and wave power. And those 3 technologies are at different levels of development. Some we've done only small-scale testing, others we have done full-scale testing. What's common about the technologies is that we feel that they're in front technology-wise. They're backed by strong IP portfolios. We have within the industry group that owns Strohm, and within Strohm we have strong technology competence. We have industrial alliances with NLI and Rainpower, and when it comes to business model, we want to be a technology vendor. That means that we want to connect and have alliances with local vendors when it comes to delivering large projects. So, delivering projects in Portugal, we want to team up with Portuguese vendors to help us realize the projects. And we feel that all our technologies are able to produce energy at competitive cost levels compared to other technologies out there. So I'm going to start talking about tidal. Although tidal is not a big issue in Portugal, it's not very sort of potent technology in Portugal. The reason I mention is that that's the technology that we have full-scale experience from. The technology is a floating tidal turbine. And the reason for that is that the best tidal streams is close to the surface. So it's better to be far away from the seabed. You have less turbulent water and also the strongest currents near the surface. On this picture, it's only a small portion of the installation that is showing. This picture gives you a better impression of the size of the technology. The green part on this picture was the part that you could see above the surface on the first picture. As I said, a floating structure with 4 turbines, a total installed capacity of 1.5 megawatts on this structure. It's floating just below the sea level, sufficiently below the sea level to have no interference with boat traffic and so on the turbines, and it's anchored in each end. As I said, 1.5 megawatts installed capacity for this platform. It can be increased to larger installed capacities, but that was chosen for this one. The total weight of this prototype is 410 tons and has a potential to produce 5 gigawatt hours per annum. The turbine diameter is 23 meters for each turbine. And it's anchored and can be sort of positioned at the right depth. It carries a full vessel certification. That means that it can be towed legally and it can be docked as a vessel. And that has advantages on the operation and maintenance side. The platform can be accessed during operation, and you can do maintenance. You can surface the vessel and do maintenance at site. And it also has installed capacity to be remotely operated, which has also advantages on the maintenance and operation. Currently, it's not producing. We had some structural failures during the first test run, so we have to do some adjustments and repairs, but it has been installed and grid connected and has produced energy to the grid, although relatively limited. But we're working on getting it installed again. So the wave power. This technology is actually a technology that was inspired by a Norwegian industry project all the way back in the 1980s. It's based on the oscillating water column principle that we've been presented to earlier. And quite a few of the people that were involved in the Kværner project in the 1980s are now part of our project, although the technology as such is not exactly the same. What we've done is go back and to look at how to optimize both the wave power, also energy uptake from the waves, and also optimizing the turbine itself. As the turbines and the WavEC power technology is patented earlier, we look at how to optimize the technology. So we've been looking both at the structural design, how to get the most energy out of the oscillating chamber, and also the turbine. The oscillating water column principle was described earlier today, but I'll briefly go through it. The point is to have an absorption of wave on the point absorber principle, and that means that you can actually catch wave or wave energy from a broader sector than the actual dimensions of your moving body. That allows you to have a large energy uptake. Secondly, your point absorber, the moving water column, moves back and forth in the oscillating chamber, pushing air in front of it, and of course then pushing the air back and forth through an air turbine. This is a picture taken from the project that was done in the 1980s. That proved that the oscillating water column principle as such was a viable technology. That project ran for several years. It's not our technology as such, but it sort of proves the oscillating water column technology in principle. So a little bit about our testing. I said that we both done tests on the wave uptake. So this picture shows, it's actually a plexiglass model, so it's a bit difficult to see it, but it's a small model of the oscillating chamber. And we tested it in WavEC to see how alterations of different dimensions and parameters affect the energy uptake. We got some quite good results on that. And we're also getting ready to do a test of the turbine itself. So we tested or built a turbine test facility in small scale, which you can see here, and we are getting ready to do tests on that. So that's in principle a large fan that's going to simulate the oscillating wind or airstream through the turbine. So oscillating water column, the advantages of course is it's a compact turbine. It's one turbine packed in a small compartment, few moving parts. It's adaptable both to onshore or near say shoreline installation and offshore installation, as was presented earlier. It's ideal for breakwater, where you already are going to install a large infrastructure. It's cost effective to install or integrate this technology into a breakwater. Maintenance is relatively easy, as you have a small compact turbine, and in our view a low cost installation cost. So the last technology I'm going to talk about is offshore floating wind power. As you can see from this artist's impression, it's a semi-submersible platform, triangular semi-submersible platform, much like wind floats or Principal Power's wind float project. The difference is that we have 3 turbines on the platform, and it's a bit larger platform. And there are some differences between, but in principle, semi-submersible platform that is very stable, as WindFloat also has experienced. Some of the numbers. We've done a design for a 3 times 3.6 megawatts installation. It can be with larger turbines. The reason for the 3.6 was that at the time we started the project, that was the largest offshore turbine in the market, but we have later looked at 5 megawatts and 6 megawatts turbines. As you see, it's three turbines. The total weight of our construction with those 3 turbines would be about 3,700 tons. It can operate in water depths from 45 meters and deeper. Has a draft of about 23 meters in operational mode, and about 8 to 10 meters in transport mode, meaning it can go to any dock. The question that many raises when it comes to putting 3 turbines on a small platform like that is, what about interferences? What about wake effects? What about turbulence? What about shadowing out of the rear turbine? That's important questions. One important principle on our turbine is that it's anchored under the center by a turret. That means that the entire platform can rotate around its axis. The turbines on the towers themselves does not rotate, but the entire platform rotates. That means that the 3 turbines, or the constellation of the 3 turbines, will meet the wind in the same fashion at all times. And that means that you at all times will have 2 turbines in front and 1 turbine in the rear. The rear turbine is on a bit higher tower. That means it's partly out of the shadow of the 2 front turbines. When it comes to turbulence, we see that the large energetic turbulence that's dangerous to turbines takes longer time to develop than the distance between the turbines and our platform. Means that the turbulence develops further behind. So you're actually out of the area of the turbulence because you are sufficiently close to the front turbines. When it comes to shadowing effect, we have about 25% shadowing effect on the rear turbine, meaning over the annual production, you lose about 25% of the production on the rear turbine. On the front turbines, you don't have any loss, but you have 25% on the rear turbine. So that means if you look at the 3 turbines together, you have 2 times 100% and 1 times 75%. And then it's about 90 to 93% of the total maximum if you had three standalone turbines, but you only have one foundation. So you lose a little bit on the energy production, but you gain a lot on the installation cost and the steel per megawatt installed effect. This has been tested in small scale, 1 to 50 in WavEC with wind, to look at the coupled forces from wave and wind, and has been tested in wind tunnel to verify the calculations on the energy production and the turbulence side. So we're at the stage where we are anxious to move into the valley of death on this technology, trying to finance up a larger scale project, either a full scale or a medium scale project for sea installations. This slide is a bit detailed, but it sort of details out how we looked at the energy production potential. We took actual wind data from an oil installation in the North Sea and looked at how the shadowing effect would affect the rear turbine for different wind speeds, and connected that with the probability of those different wind speeds over a year, and that's how we came up with the production loss for the rear turbine. So that's valid for that particular wind regime. So that was my slides.
Thank you. Ladies and gentlemen, the organizing committee, thank you for inviting me and the possibility to talk about the Norwegian cluster model. Today I will give you a short introduction of Innovation Norway, focusing on how we work with Norwegian clusters, using Wind Cluster Mid-Norway as an example. Innovation Norway is the Norwegian government's most important instrument for innovation and development of Norwegian enterprises and industry. We support companies in developing their competitive advantage and enhance to innovation. We are an international organization and we are located in every county in Norway and is represented in more than 30 countries around the world. We offer 5 different types of services. We are best known for our financing services, but we also have good services in consulting in relation to international opportunities, providing competence, profiling and networking. A group of customers who use many of our services is the clusters that we work with. We cooperate closely with the clusters before we engage into a partnership. With a cluster, we select and prioritize the clusters. So, what are the characteristics of clusters? We defined cluster as a geographical, regional collection of companies where both R&D and educational establishment as well as public participants with a focus on development come together with a common interest in cooperation and increased value added. Further, this is preferable with a diverse group that includes both large and small companies. And it's very important to have an active facilitator in this group. To give an idea on how we work with clusters, I will say something about how we choose the clusters, how goals we set for the clusters, and how we contribute the clusters. When we selected the clusters, we arranged an annual national competition where only the best clusters are selected, with a set of selection criteria such as cluster resources, collaboration possibilities, capabilities for innovation, growth potential, and the project quality. And we use an advisory committee to prioritize the clusters in the competition. We will then have the best clusters with the best conditions for success. So, when you have selected the clusters that we want to move forward with, Innovation Norway contributes to the cluster with 5 services. That is the final support. We give 50% funding to 5 main activities. We also, and in addition, we have advisory services, competence, networking, and profiling. So, how does ensure that the cluster reach their goals, leading to cooperation and growth? Well, there are identified some success factors related to successful clusters processes, such as active and dynamic leadership. A strong resource base is necessary, a mutual common interest to cooperate, commitment, a long-term strategic perspective, action-oriented, and at least local and global interaction. So, what is the experience gained so far in Norway? We identify that cluster initiatives are important in regional and national innovation strategies we have noticed an increased demand for cluster support instruments, such as financial services together with the other services. There is a growing awareness in the business community to form partnerships, as well as a growing willingness to invest in the cluster development. Furthermore, the external evaluation of the cluster programs and the projects are very positive. So, a good example of this successful cluster is the Wind Cluster Mid-Norway. The Wind Cluster Mid-Norway have more than 60 members, collecting a large part of the supplier industry within the onshore and the offshore wind in Norway. To cut the story short, there were some leading companies in a small industrial town, Verdal, in Nord-Trøndelag, who started the conversation about the cluster cooperation. This developed further, and in short time new companies showed their interest and want to join the cluster. The Wind Cluster Mid-Norway applied the cluster program in 2009, and so far they have reached funding for 3 years, and now they got funding for 2 more years, because we see that there is a great potential in the cluster for the development. The cluster has grown both regionally and nationally. They have created an attractive cluster with a strong focus on international links, particularly with Germany and Great Britain, and the cluster is now open for the new partners in Portugal. The cluster has established a good relationship with national research units which in the field of offshore wind in Norway, for example SINTEF, NTNU and NOVITEC, which are the Norwegian Wind Research Center for Offshore Wind Technology. So, there are some of the members of the cluster present here today, as Kongsberg Maritime, Windsea and Åk, and others, and I could use all of them as a good example for good cluster. But let us take more look at the company Åk as a good example of cluster cooperation. Åk is, what you heard earlier today, is specialized in access to difficult to reach location in demanding environments. They have the experience from the oil and gas industry, they have the competence within the offshore wind sector, they have a clear strategy to work through networks, such as Wind Cluster Mid-Norway and others. They have worked closely and well with the companies in the cluster to grow, both nationally and internationally, in cooperation with Innovation Norway. They saying that they had not been where they are today without the cooperation of the cluster helped to come into a sector where it's been possibilities to get contracts. The Norwegian actors in the offshore wind are building further on the expertise built up during over 30 years of construction, operation and maintenance of oil and gas development in the North Sea. Wind Cluster Mid-Norway have seen the value chain mapping need for value chain mapping in the cluster, and has developed a supplier database that is very good for the companies in the cluster, but also very good for the companies outside the cluster, for overview of expertise and services the members can deliver. This is one of the first supplier database for offshore wind in Europe. The database has collected much of the country's wind actors and provide an overview of what can be delivered from the country, from which company. So for those who want more information about this supplier database, it's recommended to take a look at the base at the following internet link. And if you do that, you have the option to choose segment of value chain that you want to learn more about, and find a company that can contribute to development and providing services in the area you are particularly interested in wind energy. So, we hope that many of you will take the time to get known with the Norwegian companies that are present today and become more familiar with the supplier database. So finally, I will say that the wind cluster Mid-Norway does not come here as competitors, but recognize the value of building strong partnerships between Portuguese and Norwegian companies to jointly solve the challenge in the offshore wind. Thank you for your attention.
He is also developing his doctoral thesis on underwater imagery in the doctoral program Advanced Telecommunications Engineering at the Institute for Applied Microelectronics. Mr. Eduardo Quevedo, please.
Thank you very much. First of all, I would like to thank the WavEC Energy Center for the opportunity to present Tropos today. The Tropos project is intended to design a multi-use offshore platform for tropical, Mediterranean and subtropical scenarios. In my presentation, I will give a brief introduction and then I will present the challenges and objectives of the Tropos project. I will introduce then the consortium of the project and pass to the plans and what is the progress till now. Finally, I will conclude with some comments. The Oceanic Platform of the Canary Islands is the organization in which I am working and is also the coordinator of the Tropos project. It's a project half funded by the national government and the regional government of the Canary Islands. And its main objective is to design and build an offshore platform for research and innovation in the marine and maritime sectors. This is going to be a fixed structure with 4 kilometers offshore and a depth around 30 meters. It is going to be located in a strategic position in the Gran Canaria Island. The contract for its construction is already signed with Acciona and is going to be in the eastern part of the island, which is a strategic location because we can reach deeper positions easily because we are very close to the continental slope. We are in a position quite strategic, as I said, because we have a port, Puerto de la Luz, which is used to work with offshore platforms. At the moment, we have the biggest oil rig in the world in this port, and we are going to use all these logistics to take part in the Oceanic platform. We have also an onshore position close to the future position of the platform, and in here we have some laboratories for the testing of marine and maritime devices and to prepare some national and international projects. We are working closely with the Canadian Marine Institute and with the local university. And this is going to be, this is the idea of the platform. We are now working in a marine test site with some wave energy converters, and the platform will be also based on aquaculture. And if we go underwater, we can see some underwater vehicles. We are working now with the gliders, and also we are trying to constitute a marine observatory. So we also work in European projects, and probably the Tropos project is the most important one for us. It's a project that is based on the challenge that means the fact that in the year 2005, more than half of the population live in positions close to shore, and this situation is going to be doubled in 20 years. So the challenge is to share sites, infrastructures, in order to be able to share the space in different activities, such as the transport, the energy, the aquaculture, or the leisure. For the energy component, sorry, I think there is a mistake in this slide. We are going to combine the wind energy, it should be in there, with the ocean thermal energy conversion, the current energy, and the wave energy. Only for the wind energy, we have an increase of more than 20% per year. So the space should be shared with other activities such as the maritime transport. This is the idea of having an offshore port and use this port for all the infrastructure and logistics associated offshore. Also, the aquaculture is going offshore because the space in the shore positions is very limited, so we need to face strong currents and deep waters, and this activity is also going offshore. And as an added value, we are considering also the laser. The laser could go from ideas of underwater restaurants, hotels, and why not thematic parks. So the idea of the project is to combine all these activities in one single location, this idea of the multi-use offshore platform. And this is only one project of the Ocean of Tomorrow 2011 call related to multi-use offshore platform, but there are also 2 other projects funded by this call. The first one is the H2 Ocean, which intention is to develop a wind wave power platform and also considering the hydrogen as an alternative energy. And the other project is the Mermaid for the planning, design and operation of multi-use offshore platforms. So the objective of the Tropos project is to design 3 offshore platforms in Mediterranean, subtropical and tropical scenarios, trying to combine all these sectors that I mentioned before: the transport, the energy, the aquaculture and the laser. But for this, we need to assess if this is economically feasible and viable. And of course, to take into account the environmental impact assessment of the platform. So for this, we have constituted a consortium of 18 partners from 9 different countries. In this consortium, we have included SMEs, enterprises, research organizations, and the Wave Energy Center is participating in this consortium mainly in the resource assessment and the wave energy potential. And we are also integrating a third-party partner from Taiwan, which we consider that is also very positive for the project. We are planning this project in 8 work packages. 2 of them are related to the general management of the project and the scientific and technical coordination, and 1 more for the dissemination of the project. Then we have an iterative work from the work package 2 to the work package 6. The work package 2 is led by the Wave Energy Center and is related to the initial constraints of the platform, and this goes into the concepts which are defined in the work package 3, and finally the engineering in the work package 4. Parallel to these 3 work packages, we have the economics in the work package 5 and the environmental impact assessment in the work package 6. So we have organized all this work in 3 years, and we are at the moment in the month 10th of the project. So I will try to tell now what are the progress till now. We began with this initial idea of a central unit with central modules and satellite units for the platforms. This is an artistic representation of the platform. And what we want to do is to combine these 4 sectors to find synergies among them. These are the transport, the energy, the aquaculture, and the laser. So I will introduce the example of the Canary Islands. As I explained, we have existing port infrastructures in the Canary Islands, so we can use this sector. We have also an important local mix of energy resources, mainly based on wind and wave. We have some aquaculture projects around the island, and we have also 1 project of offshore aquaculture. And the laser and the tourism is the main driver of the local economy, as you may know. So what we have done is to try to define initial locations with a main component: the transport, the energy, the laser, and the aquaculture. And what the Wave Energy Center is doing at the moment is to define a GIS decision tool in order to combine all this information in 3 locations: the Canary Islands, Greece, and Taiwan. And in this way, in the island of Crete in Greece, 3 initial locations have been defined, and the same has happened for Taiwan. So at the moment, what we are trying to do is to define some extreme concepts for the platform, and we have considered that the laser, if we want to exploit the laser in the platform, it will be probably in a position not too offshore, but in shallow waters. So we think that the possible configuration for the platform should be more something like this, an industrial complex with as we foreseen, a central unit, and try to use this central unit as a central tower for the rest of the components of the wind and the aquaculture, trying to combine the energy and the aquaculture concepts with a common foundation. And with all this information, what we are doing right now is to define the technologies that we are going to use at the platform. This activity is led by the Fraunhofer Institute. So this project, finally, as a conclusion, will deliver 3 offshore platforms in 3 regions: the Mediterranean, the tropical, and the subtropical. We have defined Greece, Taiwan, and the Canary Islands as use cases. And the idea of the platform is to try to find synergies among different sectors, and these are the transport, the energy, the aquaculture, and the laser. Thank you very much for your attention.
Please, Jack, the floor is yours.
Thank you for the introduction. I would like to thank you for the invitation that was made to me to be present in this event. My congratulations for Wave Energy Center and the Norwegian Embassy for this initiative and in the way which is organized this event. The challenge for me today is to talk about the OTEO project, an initiative led by INEGI in a partnership with Wave Energy Center and Energin. The agenda for this presentation consists of a brief presentation from INEGI and followed by the framework, objectives and activities of the OTEO project. For those who don't know INEGI, INEGI, the Institute of Mechanical Engineering and Industrial Management, is an interface institution between university and industry and oriented to the activities of research and development, innovation, technology transfer. It contributes to increase the competitiveness of the national industry through research and development, technology transfer and training in fields of engineering design, materials, production, energy, environment and industrial management. INEGI has the collaboration of the professors and researchers of the University of Porto, its own staff and trainees and technical research. On its main board, more than 150 employees, of which nearly 80% are seniors. INEGI has a broad range of skills, such as forecast energy resource monitoring, geographic information systems, instrumentation, mechanical design, composite materials, rapid prototyping, preventive and predictive maintenance, tribology, and training. This set of skills has to answer the various challenges related to renewable energy offshore. As I referred earlier, is active in research, innovation, technology transfer, consultancy and service to a broad range of markets and activity sectors, such as automotive and transport, aeronautics, space, defense, environment, energy, and sea economy. The Institute has over 25 years of experience in projects with companies as well as national and international consortia. Few examples of the projects we participate are shown in these slides, as well the companies we work with. For example, ESA, Airbus, ADP, WavEC, and others. Related to renewable energy, more than 80%, in particular in wind, more than 80% of wind power installed capacity has collaboration from Energy. Now we are present in 11 countries from 3 continents doing wind power consultancy. C projects. C projects in Energy, we have a preference in developing technologies in areas such as aquaculture, industry offshore, underwater robotics, and in particular offshore renewable energy, with development of equipment for monitoring offshore wind resource and development wave energy conversion systems. The acquired knowledge of the various projects in which Energy participates and attempt to potential offshore renewable energy in partnership with Wave Energy Center and Energy in promotes the OTU project. As said before, Wave Energy Center, as shown in this seminar, is a non-profit organization dedicated to development and promotion of ocean wave energy, offshore wind, and other forms of marine energy. Energy is a non-profit association that aims to cooperate with companies and R&D institutions. Identify partners for us is important to justify why we promote offshore energy technology observatory. Portugal and its regions have a strong connection to the sea. This historic and cultural connections and economic and social dimension has evolved over the years. Betting on the economy of the sea, and in particular offshore energy, corresponds to a national goal. The strategic importance of the ocean and seas has been widely recognized internationally. The ocean is one of the lesser explored resources of the planet. This enormous surface receives the largest amount of energy emitted by the sun. The oceans are an important source of energy available, and offshore renewable is a challenge with great potential to meet the future energy needs of the planet. I think the numbers speak for themselves. The ocean is a huge resource with 275 million terawatts per year, and world energy consumption 140 million terawatts per year. The offshore wind and wave energy target for 2050 is set at European and international level. The future benefits depends on how we explore the knowledge of these resources, how to prepare the future for their sustainable exploitation and investments we make. Portugal, as shown before, is a pioneering country in some of these offshore renewable energy, particularly in harnessing of wave energy and offshore wind. Projects like PICO, AWS, Pelamis, Wave Roller, and Wind Float. The knowledge of enabling technologies are indispensable for the proper function of offshore energy generation technology. In many cases, the companies that install their technology in Portugal contract the service outside of Portugal for lack of available facilities, or in many cases because there is no hand of skilled labor in Portugal. Examples of technologies support vessels, moorings, seas, electrical cables are these enabled technologies. In previous presentations, all shows the economic exclusive zone. I think don't refer that the Portugal has the third largest exclusive economic zone of the European Union and 20th largest economic exclusive zone in the world. Portugal submitted a claim to extend its jurisdiction over an additional 2.15 million square kilometers of the neighboring continental shelf in May 2009, resulting in an economic exclusive zone with a total of more than 3 million square kilometers. Our comparative advantage result from the characteristics of our coast, medium or to high energy resource, relatively deep waters near the coast, the availability of support infrastructures along the coast, and the relevant technical and scientific knowledge. This form of energy is likely to have great impact on Portugal and national companies. The level of renewable energy production, job creation, innovation, and export of goods and services. The appearance of several technologies advise that there should be a deep reflection on the technology evolution that is occurring, that the correct decision may be made in terms of present and future. OTEO project aims to create a network of Portuguese and international experienced experts in offshore energy projects by monitoring the activity carried out in the main European research centers, identify opportunities and threats, strengths and weaknesses of offshore energy technology from concept to deployment, analyze offshore energy technology investment project. These initiatives are essential to contributing to policy and to minimize the risk options. Attracting the involvement of a large number of companies is fundamental. Main objective is create a directory of national entities, identify competence for development of offshore energy recovery projects, create a technology roadmap that identify actions, their schedules and costs to develop a national offshore renewable energy sector that maximize the national value chain. Create event organization and an international conference on the theme offshore renewable energy, what solutions can be developed in Portugal, and a book publication on offshore energy conversion technologies to disclose internationally. In accordance to activities planning project, we have concluded the first with the publication of the report of the state of the art with the contest that is shown, like resource forms of exploitation, main actors, barriers to development, potential objects and goals. The international conference we organized, that conference was attended by over 200 participants interested in the subject from different countries. We had the honor of having the President of the Portuguese Republic, Professor Aníbal Cavaco Silva, in our presence, which is promoted by the project. We are currently completing the second, third, and fourth activities. The resulting information for these activities will soon be published. The remaining activities are underway, and we intend to have them complete by the end of August 2013. It is our intention, because this is a financial funding, it is our intention to keep this project active after 2013. With constant updating of information available in our website. Our new website will be shortly online. You may consult current information on the following link. Let me thank you for your attention.
Thank you. To be a challenge to be a technology developer at EDP, but no, in fact, I'm a manager of a small company, an SME company, Hidromod, which is turned 20 years this year, and we develop software, modeling software, numerical models, information technology applied to, well, whatever has to do with water, in natural cycle or in urban cycle, or whatever is around water, and then that's it. And when I left university, I started working in these areas, and I started working along with people who were working with the Pico power plant, which was in those days a very nice project. I'm going to talk about data management platform, and this is the way to attract your attention to a specific project called Sophia, where Hidromod is one of the partners, and we are working along with the Wave Energy Center. I'm going to make a very brief presentation of the Sophia project, and then I'm going to focus on the platform and the structure of the platform, how it was structured, how we put in the data, what data, how you can access it, what's the interface, how can you you can get to the information behind that data. So Sophia is something like easing the process of permitting of wave energy devices, projects within of wave energy. So the aim, and I may read it, is to facilitate the development of European-wide, so it has partners from Portugal, Spain, England, Ireland, France, Belgium, I think. So we want to streamline this environmental impact assessment, and we want to produce tools that help that. The data management platform is one of those tools, and it had some requirements we proposed when we made the proposal of this project. It's financed by Intelligent Energy Europe. So the data we put in must be compliant with the INSPIRE directive. So for each set of data there's a set of metadata that tells where it was measured. It gets some information on the data. It's stored in a easy to access place, so reliable in the cloud. It must be easily accessed by partners. So data must be easily uploaded by partners and even more easily accessed by users, by the target groups. The data is data from whatever data we can get from the sites that are the object of the project. So mainly European sites, and also some models, and hopefully remote sensing, and it should have a reporting service. Okay, the partners of the project feed in the data they have, feed in the data they can harvest. For instance, in Portugal, REN provided a very good set of information on the Ocean Plug site, which is already there, so you can go there and see it and dive into it. So this is the interface of that the partners of the project can use to enter the data to the platform. It's not of much use to you, but then what will you see? You can go to this site, you can filter between projects, wave energy projects that were already made or that were in projects. So there you have the information on that. And you can go to specific sites and see what information is available at each site. And I will use the Ocean Plug site as the example. And you can visualize data in a GIS format, a web GIS. You can immediately visualize time series. So whatever data was input there in a CSV format, so comma separated value format, you can visualize some shape files, XYZ files, etc. And most of all, you can download the data. Okay, so you can visualize this data in a very fast way. So we don't have a very sophisticated way to visualize shape files, for instance. You can see some information, but if you want to make a more in-depth analysis, you just download the shape file and use your own software to analyze it. But here you can mix these shape files with mix the information you want. Okay. So this is the first window of the project of the site, where you can see specific projects, and you can go and click. In the left side, you can filter the information. So if you want to see all the projects that were made in Portugal, you just click in Portugal, and then it automatically selects all the projects in Portugal. If you want to see the oscillating water column projects, it filters those projects, and then you can dive in the information and see the specific information on each project. Then you have specific locations of these sets of data. Okay, so there's the ocean plug there, and others in Europe. The project is still going on, so we still haven't finished this, but it's already available. Although, if you want to filter the information, once again on the left-hand side, you just go and see. I just want to see the ocean plug. So if you just want to see the ocean plug, then you will see a list. Once again on the left-hand side, all the data that's available there. You can click and see where it is. You can, for each set of data, you have metadata information, where it was measured, who measured it, if it is available or not. So if it's not available on the platform, you can find an email, or you can find somewhere a way to reach that information. But if it is available, if it is on one of the formats that you can visualize in this WebGIS, you can visualize it. And you can mix the information from different sites in Europe. And then there's also a part for model information. So you can go there, and we are right now doing this part of the work, and you can find a few years of reanalysis of modeling of waves. So you can find there, for instance, time series for the last 7 years in a very large part of the North Atlantic, of significant wave height with a time interval of 3 hours. So you can get that information in any site you want, and you can mix that with other data. This is where we are right now, so inputting more and more information, and also doing this part of automatic reports on data. We will be able to select specific data, to select a pre-formatted report, and then a PDF, a Word, an Excel file can be automatically generated by the platform and sent to you. Okay, this is a kind of report that we do in other platforms, but it will be the same here. So you just select a period of time, you select some kind of area you want to see, and it will look something like this. Okay, in this case, it's a PDF report that can be generated with wave information. We will be available after this session to demonstrate this platform in 1 or 2 or 3 computers, I don't know, and downstairs. Downstairs we will be demonstrating this if you want to see it and have a feel of this. This is the site of the project and the site where the data platform can be seen. Thank you very much.